Hello guys, you're welcome to my channel. So today we are going to be looking at some expression on indices. Now when you talk about indicial expression, what differentiates indicial expression from indicial equation is the equality sign. Now can we solve this? When you are given indicial expression or equation, the first thing you should think is how to generalize the common base or how to make their power to be equal. Because if there is no equality in the power or base, most of the law or virtually all the law might not be able to be applicable to the question. So when you are given a problem on indices, what we have to think is how can we make it to be the same base? If it is not possible, how can we make it to be the same power? And this is the secret. When you have an unknown as power, or the power contain an unknown, like you have this now, x is unknown here, just know that it's not possible for you to make the power to be the same thing. So you think on how the base will be the same thing. And if your unknown is the base, it shows that you have to be thinking on how the power will be the same thing. Now let's solve this. We already have unknown as the power. Now let's see how the base can be the same thing. 5 to the power of 2 is 25. 5 to the power of 3 is 125. So this will become 5 to the power of x times 25, times 5 to the power of 2, then the former power rather, you put it in the bracket, divided by 5 to the power of 3 x plus 1. So we can now open these brackets now. I will be having 5 to the power of x times 5 to the power of 2x minus 1 divided by 5 to the power of 3x plus 3. Then I can apply the first law to this, since they are product and they have the same base. So I'll pick one of the base, 5x, and add the 2 power, 2x minus 1, divided by 5 to the power of 3x plus 3. If you don't understand this law, you can kindly check the description box below. You see the links to the former class there, where we talk about the laws of indices. So I have to apply the second law, which is the division law. So I will have 5 to the power of 3x minus 1 minus 3x plus 3. So this will become 5 to the power of 3x minus 1 minus 3x minus 3. Sorry, there's a mistake here. This is supposed to be 2. Because 2 times x is 2x. 2 times minus 1 is minus 2. So this and this can cancel. Then I will have 5 to the power of minus 5, because this is minus 2. Minus 2 minus 3 will give us what? Minus 5. So the correct answer to this expression is 5 to the power of minus 5, and that is option C. It's jump question 1979, number 19. So let's move to the second question, 9081, number 26. Now in this question, or let me say this particular question is a bit different from the first one, but we think of the same thing here. If you look at this, the power has nothing to do to be the same thing because we have unknown there. We can't make it to be the same thing, but let's try the base. Now the base 6, now there's a problem. We can't write it as a power of anything. 18, the same thing, and as well 12. But we can write 9 as 3 to the power of 2. We can write 4 as 2 to the power of 2. We can write 2 as 2 to the power of 1. All these ones that cannot be written in power of anything, we can break them into products. That is what you should do. So this can be 3 times 2 to the power of 2n plus 1 times 9 to the power of n times 4 to the power of 2n divided by 18, that's 2 times 9 to the power of n times 2 to the power of n times this 12 will become, let's say, 3 times 4 to the power of 2n. This will later become 3 to the power of 2n plus 1 times 2 to the power of 2n plus 1. This is one of the law that we expressed in our last class. So this will be 9 to the power of n times 4 to the power of 2n divided by 2 to the power of n times 9 to the power of n times 2 to the power of n times 3 to the power of 2n times 4 to the power of 2n. So 9 to the power of what? N will cancel each other. 4 to the power of 2n would cancel each other. So we are left with 3 to the power of 2n plus 1 times 2 to the power of 2n plus 1 divided by, this is 2 to the power of n, 2 to the power of n, so it can be 2 to the power of 2n times 3 to the power of 2n. So this can be written as 3 times 2 to the power of 2n plus 1 divided by 2 times 3 rather, to the power of 2n. So this should be 6 to the power of 2n plus 1 divided by 6 to the power of 2n. So I'll apply the second law, and now we have that 6 to the power of 2n plus 1 minus 2n equal this and this cancel. So I have 6 to the power of 1. And that is my answer, D. So let's move to the next question on our list. Now, this particular question here, it has nothing to do with an unknown. This makes the work very simple. So, can the base be the same thing? Yes. For now, the power can be the same, because 3 over 4 cannot be written as 1 over 3. So 81 can be written as 3 to the power of 4. Then we have 3 over 4 minus 3 to the power of 3 raised to power 1 over 3 divided by 3 times 2 to the power of 3. So one of the law that we've discussed, this and this we cancelled. This and this would also cancel. Then we have 3 to power of 3 minus 3 to power of 1 divided by 3 times 8, because 2 to power of 3 is 8. So 3 to power of 3 is 27 minus 3 divided by 3 times 8, that's 24. Then we have 27 minus 3, that's 24 divided by 24. This and this will cancel. Then we have 1 to be our answer. So we have the next question. Jam year 2000, number 9. Now, if you look at this particular one, it's absolutely different from the one we have been solving before. In what sense? There are some digits that takes what? The unknown, and some has nothing to do with the unknown. They are also simple to attempt. So, let's see. This particular one here is 3 into 2n plus 1 minus, there is a common base between this and this. So this is simply 2 to power of 2 times 2 to power of n minus 1 divided by 2 to power of n plus 1 minus 2 to power of n. Then this should become 3 into 2 to power of n plus 1 minus, this should be 2 to power of 2 plus n minus 1 divided by 2 to power of n plus 1 minus 2 to power of n. So this should become 3 into 2 to power of n plus 1 minus 2 to power of n plus 1 divided by 2 to power of n times, this one will become 2 to power of 1 minus 2 to power of 1. I did this so that I'll be able to factorize out 2 to power of n here, and I'll be able to factorize out 2 to power of n plus 1 here. Hence, I will have 2 to power of n plus 1 into 3 minus 1 divided by 2 to power of n into 2 minus 1. Hence, I will have, this will give me 2. So I will have 2 to power of n plus 1 times 2 divided by 2 to power of n, because this will give us just 1. Hence, our result will be 2 to power of n plus 2, because this one will have power of 1 plus 1, 2, then minus n. This and this cancel. Hence, our result is going to be 4, which is 2 to power of 2. So the correct answer to that is C. So the last question here is JAM 1984 number 14, which I would like the audience to try and put their answer in the comment section below. Now let's quickly look at a law that will help each and every one of us in solving questions that has to do with power or non-power, and it is an expression. Please, I would like you to pay attention to this law. The law is called zero input. When you say zero input, it's absolutely what? A shortcut in solving indicial expression. Now, this particular law, I will tell you when and when you are to apply it. For instance, I have 6 to power of 2n plus 1 times 9 to the power of n times 4 to the power of 2n divided by 18 to the power of n times 2 to the power of n times 12 to the power of 2n. This is our number 2 question today. I will apply the zero input law to this and you will see how fast you can solve. Whenever you have an initial expression and the unknown happens to be the power, and listen to the conditional. Number 1, it must be an expression. Number 2, the unknown must be power. Number 3, every element, what I mean by element is every number here in this expression must have the unknown as a power. Those are the 3 conditions that you need before you can apply this law. If any of this condition is not satisfied, then don't use this law. The law will not work. Like for instance, our last question today, where we have this particular question, 3 into bracket 2n plus 1, not all elements in this case have n. Sorry, we can apply it to this. But if you look at this particular question that we have as assessment, we cannot apply it because we have 3 to the power of 3 here that does not have what? The unknown. We have 27 here which has not what? The unknown also. So because we have this, we cannot apply this particular zero input. I believe we understand when to apply it and when not to apply it. But this can be applied to question 1 and question 2 and other related questions. All you need to do is to say, let the unknown, which is n in this case, equal to 0. So anywhere you see n, you put 0. So this will become 6 to the power of 2 into 0 plus 1 times 9 to 0 times 4 to 2 into 0 divided by 18 into 0 times 2 raised to 0 times 12 raised to 2 into 0. You and I both know that this will become 6 to the power of 1 times 1 times 2 times 0 is 0. 4 to the power of 0 is also 1. Then 18 to 0 is 1 times 2 to 0, which is also 1, times 2 times 0, 0. So we have 12 to the power of 0, which is also 1. 6 times 1 times 1, that's 6. 1 times 1 times 1 divided by 1. 6 divided by 1 is 6. Your answer. So, if this video has in any way serve you right, kindly click on the like button and remember to subscribe to this channel. This will motivate me to produce more useful video on mathematics and physics. Kindly share this. Good day.